Irodov problem 1.12. 3 points are located at the vertices of an equilateral triangle whose side equals A. They all start moving simultaneously with velocity v constant in modulus, with the first point heading continuously for the second for the third, and the third for the first. How soon will the points converge? This is a very interesting problem. Honestly, I actually tried it out before doing this video, and I had a little bit of struggle understanding how to approach this problem, and that is okay because we all learn through the process. But let's restate the problem on the board and see what's the easiest way to do it. So it says there are 3 points at the vertices of an equilateral triangle, okay, and they start moving all with v, which is constant in modulus, which means the direction keeps changing but the magnitude remains the same. So first point is directed continuously towards the second to the third, and the third to the first. So if I complete the triangle, okay, you can imagine what would happen is as soon as this starts moving, the direction of this point, let's say 1, 2 and 3. As soon as 2 starts moving, 1's direction also moves. So it will start going in some trajectory like this. This will start moving in some trajectory like this, and this will start moving in some trajectory like this until they converge at a point. Now by symmetry, we can see that this point will be the centroid of the equilateral triangle, okay, and at any time t, if we look at where these particles are, if we complete that triangle, again by symmetry, because each of them would have covered an equal distance, the triangle that is formed is still an equilateral triangle. So this angles remain 60 degree. Okay. So now the question is, when will they converge? At what time will they converge? Okay, so let's look at any time t. The 3 particles are like this. Their positions still make an equilateral triangle, and let's say this is 1, 2 and 3. 3's velocity is directed this way, 1's velocity is directed this way, and 2's velocity is directed this way. Okay. The initial side of the triangle was A. Okay. Let at any point t, that remaining the side of the triangle that has formed is, let that be x. Now let's just investigate this part. Okay. So the interaction between 1 and 3. Now this is also 60 degree. Okay. Now if we just look at 1 and 3, how fast are these two converging towards each other? We'll have to take the component of velocity of 1 in this direction. So because they are in opposite directions, the relative velocity gets added up. So let's call that velocity of approach. Okay, velocity of approach is v plus v cos 60 degree, v plus v cos 60 degree, component of v in this direction. Now v cos 60 is v by 2, or we can write this as 3v by 2. Okay. Now this had been the relative velocity of approach all along. When we started with this, when we are here, so this relative velocity of approach is not changing. Okay, that is a big plus, because then all we need to reduce this problem is how fast does this velocity cover the A distance, one side of the triangle. Okay, so this then reduces to the problem if total time was t to converge, if t is total time to converge, then 3v by 2 should be equal to a by t. So therefore t is equals to 3v by 2a. Okay.